Okay, good morning, seventh grade. Here we are, lesson 5, um, continuing with probability. So, in our chance experiments that we've done so far in the lessons 1 through 4, those have all been experiments where the outcomes were equally likely, like rolling an even number cube or flipping a coin. Those events, those outcomes of those events are equally likely, heads or tails. So that's not always the case in real life, and you can have most events, that you would deal with would maybe have different chances of occurring. So the way you get the probability is through studying a lot of data analysis. And we're not doing that part. What we're doing is looking at somebody's data that they've already calculated the probability of an event, and then we're answering various questions um, about probability based on the information that we're given. So in example 1, this somebody has studied very carefully Jenna when she goes to the farmer's market, and she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So somebody studied this, and they've calculated over time. You've gotten a lot of information and calculated a lot of occurrences of Jenna going to the farmer's market and how many bananas did she buy. So they've determined that the number of bananas she buys has this amount of probability. So the probability that she buys 0 bananas is 1/10. The probability that she buys 5 bananas is 3/10. Okay, and so on. And you'll notice that these will always add up to 1. Okay, so just quickly, let's do a check. 3 plus 2 is 5/10, plus 2 more tenths is 7/10, plus 3 more tenths is 10/10, or 1 whole. So quick check that these all add up to 1. Okay, so now let's answer some questions and see how we do this. So what's the probability that Jenna buys exactly 3 bananas? So I want you to write it like this: probability of 3, because you want to write a complete mathematical statement, is, and this is just straight from the table, the probability of 3 is 2/10. Done. Okay. What's the probability that Jenna does not buy any bananas? Well, that's the probability of 0, and that would be 1/10. What's the probability that Jenna buys more than 3? Okay, so more than 3 would be 4 or 5. Either one of those would be more than 3. So I'm going to write it like this: 4 or 5. You can write out the words more than 3 if you want, but I think it's more straightforward to say, we're really looking for the probability that she buys 4, which is 0.2, or 5, which is 0.3. So you just add those probabilities together, because either one of those will be considered, you know, the particular will be considered the event we're looking at. If she buys 4, that's more than 3. If she buys 5, that's more than 3. So you add them up. What's the probability that Jenna buys at least 3 bananas? So what does that mean? At least 3. At least 3 means 3, 4, or 5. You can write it like that. And then you just add up all those probabilities. And so that would be 0.7. And then what's the probability that Jenna does not buy exactly 3? Okay, now this you're going to have to think about for a minute. If she does not buy exactly 3, then it's any of these events here except for the 3. Well, we already know, so you could write it as probability of 0, 1, 2, 4, or 5. And then you could add up all those probabilities: 0.1, 0.1, 0.1, skip that one, 0.2, 0.3. The quicker way to do that, though, is to use what we know that all these probabilities add up to 1. So it's everything minus the probability that she get 3 bananas, and you can quickly determine there's a 8/10 chance that she does not buy exactly 3 bananas. Okay, but this will add up to 8. 3, 4, 5, 6, 7, 8. So if it's everything but 1, you can just subtract the probability of the one it's not from 1. That's why we need examples. Okay, so okay, this part right here is exactly what I just told you. Okay, so taking 1 and subtracting the probability of the event gives us the probability of something not occurring. Okay, so this is kind of helpful right here. All right, so I've already gone through these. Jenna's husband Rick is concerned about his diet. On any given day, he eats 0, 1, 2, 3, or 4 servings of fruits and vegetables. And the probabilities of him doing that are given in the table. Okay, so the hard part is collecting all this data and figuring this out. And that's what statisticians do and people that are in data analysis. So all we have to do is use this information that they're giving us and answer questions. So on a given day, find the probability that Rick eats 2 servings of fruits and vegetables. So that's going to be straightforward. So you write it like this: probability of exactly 2, and it comes straight from the table, is 0.28. So what's the probability of that he eats more than 2 servings of fruits or vegetables? More than 2 would be 3 or 4. Okay, more than 2 does not include 2, so be careful. And write down what you're looking for like this, and then go to the table and just pick up the probabilities and you add them together and you get 0.51. Probability of at least 2. Now this changes it, because if he eats 2, that's at least 2. If he eats 3, that's at least 2, or 4. So there's 3 events that we have to add together, 2, 3, and 4, to get the probability that he eats at least 2. Now we have to find the probability that Rick does not eat exactly 2 servings of fruits and vegetables. So that would be everything but 2, okay? So now we can say the probability of not 2, that would be 1 minus the probability of 2, because it's everything else. And the probability of eating exactly 2 is 0.28. So the probability of him not eating exactly 2 is 0.72. You could also add up all the probabilities except for the one for 2. That would work as well, just a little bit longer. Okay, example 2. Lewis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. So the number of calls are anywhere between 0 and 4, and these are the associated probabilities. Find the probability that Lewis receives 3 or 4 phone calls. Okay, so the probability of him receiving 3 phone calls is 1/3, or 4, so you have to add that together. Anytime there's 3 or 4, or a multiple number of things that could happen, you want to add the probabilities together. Okay, so we do that, and I just quickly converted 1/3 to 3/9 using what I know about equivalent fractions. So this is also a review of fraction addition. When they give you the probabilities in fractions, your answer needs to be in a fraction. Okay, so you can't use your calculator to convert to decimal. I want your work. I want to see how you work with the fractions. It won't be that difficult. So show me your work. All right, so the answer is 4/9 for that one. Find the probability that Lewis receives fewer than 2. Okay, now I wrote this one a little bit different. Fewer than 2 means 0 or 1. Okay, I wrote the probability of less than 2 is the way I wrote it, but you could also write the probability of 0 or 1. Okay, and it will be the same. 0 is 1/6, 1 is 1/6, so you add those together and you get 2/6, which reduces to 1/3. And then this is just changes slightly. Find the probability that Lewis receives 2 or fewer. So I wrote less than or equal to 2, but you could also write the probability of 0, 1, or 2. Okay, and then you would add the 3 probabilities from the table. And again, you have to convert to fractions who have a common denominator and add them up and then reduce to lowest terms, which is 5/9. Okay, find the probability that Lewis does not receive 4 phone calls. So if it's not 4, go back to your table. If it's not 4, it's 3, 2, 1, or 0. So it's everything else. We know that these probabilities add up to 1, okay? And therefore, we can just subtract the probability of 4 from 1 real quick and get 8/9, okay? Exercises 3 through 7 are back to Jenna going to the farmer's market. She usually buys broccoli, and the possible number of heads of broccoli that she buys and the probabilities are given in the table below. So she will buy between 0 and 4 heads of broccoli. Probability that she buys exactly 3, straight from the table. Look how I wrote probability of 3. Probability that she does not buy exactly 3. So that's the probability of not 3. So that's any other thing from the table besides 3. So that way I can use the 1 minus trick. And the probability of her buying 3 is 1/4. So the probability of her not buying 3 would be 3/4. Okay, the probability that she buys more than 1 head of broccoli, that would be greater than 1. That would include 2, 3, or 4. So we add up the probability of 2, 3, or 4. And I didn't find the answer there. So let me quickly do that. 1/4 is the same thing as 3/12. So 5, 8, that would be 9/12, and that reduces down to 3/4. 1/4 is 3/12. So this adds up to 4/12, which reduces down to 1/3. That's the probability of at least 3 heads of broccoli. At least 3 would mean 3 or 4. So I add those probabilities and get 1/3. Okay, now we go to a spinner where it's like a clock. It says it's designed like the face of a clock. Well, hopefully you're familiar enough with clocks to know that they're divided evenly into 12 parts. Okay. The sectors of the spinner are red, blue, green, and yellow, but you can see visually that they are not even. These are not equally likely events. So we have to now figure out, they're not telling us the probability, we have to figure it out based on what we know about the sectors of a clock. So for red, it's just between just this first section, which would be 1 out of 12 equal parts, or 1/12. So the probability of the spinner landing on red would be 1/12. For blue, you can see that's 2 sections, okay? 2 sections are going to be blue, so that's 2/12, which reduces to 1/6. Green is 5 sections, 1, 2, 3, 4, 5. So that's 5 out of 12. And yellow is 4 out of 12, or 1/3. And then they ask you from this to create a table. Now you're the one that's created the table. Luckily you didn't have to go and count people and how many broccoli heads they bought. But here's your table. This is going to be your data table right here, okay? That we have to answer these next 2 questions. Find the probability that the pointer stops in either the blue or green region. So that's probability of blue or green. And then you go back to the table. Blue is 1/6, green is 5/12. You add those together and you get 7/12. Find the probability that the pointer does not stop in the green region. So that's the probability of not green. All right, if you get not green, then all you have to do is subtract from 1 the probability of green, and that would be 7/12. All right, there you go, 7th grade. That's lesson 5. Please do a good job on all your work. Don't rush. Rewind the video if you need to hear an explanation again. Come to office hours. I love seeing you. Okay, bye.